let's go through an example of how we might use some Poisson probabilities. So, turns out that U.S. airlines average about 54 fatalities per year, which, as much as flights usually freak people out, is a pretty small number compared to other modes of transport. So, anyway, 54 fatalities per year. And I say, if we model this as a Poisson, and the experiment is over 1 month, what is the Poisson parameter mu, right? So that's our mean, but over a month. So it says we have 54 fatalities per year, and we want to know how many that averages out to over a month. So in order to get that, I need to just divide that 54 by 12, right? There's 12 months in a year. So when I divide 54 by 12, I get 4.5 fatalities per month instead of per year. All right? So this is going to be my mu for this experiment. Now, before we start jumping into things, we should make sure that this actually is a Poisson experiment. And realistically, even though we may say, okay, it's over a fixed length of time, and I'm counting over that length of time, I don't know that this independence thing is really met. I don't want to get too grim with this, but let's think about how these things occur. Usually it's like a plane full of people crashes, and it's like 200 all at once. It's not like spread out random, like our observations are not randomly observed over different units of time here. It's like everything happens at once in one exact period. So trying to averages out per month, it's not like we get like one here and one here and one here, like over the calendar. It's like everything all at once. This is another problem with independence, right? This is actually not at all a Poisson experiment. But we're gonna do this how most people do things in the real world, which is just do it wrong and hope that nobody notices. So let's find some probabilities. So suppose this were treated as a Poisson experiment. We'll let y represent the number of fatalities in a 1 month period. Let's find the probability that there are no fatalities in a month. Now, considering plane crashes get on the news like immediately when this happens, we should be aware that this is actually a pretty high probability that there would be none in a month. Period, right? These don't come on the news constantly or nobody would get on these planes, right? So let's look at this. The probability that we get 0 exactly. To get this probability of getting exactly 0, right, whenever I've got an equal sign, I'm going to want to use the probability mass function table, which is the one with the equal sign in it that Minitab calls probability distribution function incorrectly, but that's fine. So anyway, this is the easiest one to get because it's straight out of the table, right? So I just want to look at that probability density function and look at the one for 0, and it says it's 0.0111. All right, so it turns out when you, right, doesn't match reality for me, right? They're saying like there's only a 1% chance that there are no plane crashes in the U.S. in a month. That doesn't match reality whatsoever. There is not such a high chance of having plane crashes every month in the U.S. It just doesn't happen. And these are like major U.S. airlines. It just doesn't happen like that. So this is just incorrectly applied Poisson experiments. And this is what happens when we incorrectly apply statistics to things. We put garbage in, we get garbage out, right? So anyway, the probability is 0.0111 if we treat this as a Poisson experiment, which is what we're doing and hoping that nobody notices. So now let's look at the next probability. The probability that we get at least 1, right? That's greater than or equal to 1 means at least 1. Well, I need to be able to write this as a CDF before I find the probability. Hopefully you already know that we've got a trick for that, right? Whenever I've got the probability of at least 1, what I'm really looking for is 1 minus the probability of getting 0, which we just got. So this is 1 minus 0.0111, I think is what it was. Yes. So when I do that arithmetic, I get 0.9889. So saying basically like a 99% chance that there's at least one fatality on an airline per month when we completely misapply what a Poisson experiment is. Okay, now the probability that we get less than 6. Okay, again, I need to write this as a CDF to do this correctly. So the probability that we get less than 6 fatalities on U.S. airlines in a month, I need to write that as, instead of less than 6, less than or equal to 5. Now that I've done that, I just need to look at my CDF table for 5. And again, I got to make sure that I'm using the CDF instead of the PMF. And when I look at that for 5, it is 0.70293. So, I told you this is actually a completely misapplied Poisson experiment. You shouldn't do any of this, but it still illustrates how we'd actually get those Poisson probabilities. As you go through the lab and homework and practice activities this week, you'll get lots of practice with things that really are a Poisson experiment, and so we're doing things all the right way. We still do it the same way, they'll just be correctly applied Poisson experiments.